Hey guys, good morning. Or afternoon, whenever you're watching this. So today we're going to talk about a couple things. Uh, at this point, activity 6.2 should be done. If it's not, that's fine too. Please just try to um, get it done by the end of this week. If you're having issues, email me so I know. Again, I'm willing to accommodate you guys. You just got to make sure you talk with me and discuss things with me. With that said, there was a lot of you that never even did 6.1. You need to do that again when we do get back to school, because according to Governor Cuomo, that's going to happen at least by the end of this month. So when we do get back to school, you're going to be required to have all this stuff caught up, and you're not going to want to do it within a week. So make sure that you guys are actually working on this while at home. I'm trying to definitely make sure that you have more than enough time to work on it. Again, that 6.1 activity, you had 3 weeks, and all you were doing was copying and pasting the same thing over and over again, just in a different format. You didn't have to look up new things every time. And then with 6.2, I did want you to look up new things, but it was only 3 objects, and it was only one thing that you had to do. So it was pretty simple. We went a little bit more in depth with that one, but it was pretty simple. So with this new activity, again, it's following the same lines here. We're just going a little bit more in depth each time. So this time, we're actually going to be talking about the functionality of the object. So far we've been talking about the artistic or the prettiness of the object. Now we're going to be talking about the functionality of the object. So we're just going to be looking at the documents here, okay? And this video is going to be a little long because I'm going through each individual thing individually. So, excuse me, keep that in mind. But we're only looking at it for today. So for this class, so if you're my 1-3 class, you'll start working on this on Friday. If you're my 2-4 class, then you're going to start working on this on Monday. Okay? And don't worry, you'll still have plenty of time to work on it, but we're mostly looking at things today. Okay, we're just kind of going through the motions, as it were. All right. Now, again, this video is going to be kind of long. I'm going to be talking a lot, so let's just get right to it. So first things first is the outline. So the outline here is basically telling you how this week is going to go. So second week's activities. In this outline, we have a couple things. One, you do have the equipment right here. Now, you should have, I don't know how the school did it, but I think they sent out these sorry. Oh my god. I got tired there all of a sudden. They did send out these packets to everyone, I think. I'm not quite 100% certain. But I know they sent out the packets. I don't know if they sent them out to everyone or not. But in the packet, this would have been one of the things on there. And it kind of goes step by step what you're going to do. And we're going to kind of go step by step with this as well. So, first thing is we're going to read the outline. But after that, we are going to read the entire packet together in this video of 6.3 function analysis. After that, and I'm going to explain how we're going to break that down. After that, we're going to read the PowerPoint, and I'm going to go through that again step by step. That way you guys actually read it, as it were. And then we're going to read later on Friday, we're going to review the attachments for the simple machines. We're going to refer to the last 2 pages of the packet after that as well on Friday. Then we're going to follow some procedures. And after that, we will be and the whole procedure, I should say, is analyzing the function of a consumer product. Before measurements and dissections, you must theorize how the product functions through a non-destructive observation. Identify your product's name and the company that produced it and answer the questions. So again, we're going to kind of go through this step by step. Finally, we're going to answer the 2 conclusion questions on page 4 of the packet, and that'll be it. So again, we're going to, whoa, what happened? I pressed something. I wasn't finished with this yet. All right, so again, we're going to go through these process and these steps right here. So that's the outline that you guys have. So that's right here. The function analysis is right above it. So this is what we're going to do. Now, with this thing here, don't worry about it right now. I'm going to give you a copy of it later. Okay, we're just going to read through it right now. So 6.3 function analysis, introduction. Have you ever noticed how children are fascinated with how objects work? Many engineers have stated that they can trace back their interest in their chosen field to their childhood, when they were tearing apart broken objects to figure out what caused them to move and function. Reverse engineering is a process that relies on the childhood fascination with objects and how they work. The process involves the study of an object's visual, functional, and structural qualities. Though it does not imply redesign, reverse engineering is often a tool that is used to aid in the redesign of an object so that its performance may be improved. Other reasons for performing reverse engineering include reducing an object's negative and environmental impacts, minimizing manufacturing techniques through the substitution of more appropriate materials, discovering how a competitor's products work, and increasing a company's profit margin. You have performed a visual analysis of selected products to identify the visual design principles and elements that give the object its visual appeal or lack thereof. The next step in the reverse engineering process involves the study of an object's function. This is done through careful observation of an object's sequential operation before it is disassembled. By first observing the product, you can hypothesize how to produce operates and then compare your predictions to your actual findings after the part is dissected. That was a lot. Alright. So, again, it gives you your equipment's list. Alright, so one of the things I will be giving you is isometric grid paper. If you can't, for any reason, use that, just normal paper is fine. Reverse engineering product analysis PowerPoint, which we'll go through. Simple machines handout, which we'll go through. Example product observation, we'll go through. So far and so forth. So in this activity, you will analyze the function of your consumer product. Before measurement and dissection, you must theorize how the product functions through non-destructive observation. Identify your product's name and the company that produced it, and answer the following questions. So, right off the bat, I'm going to tell you right now, with the activity that's going to happen after this, I would find something that actually has a function, like it actually does something. And I would pick something that's non-electronic, okay? Don't don't pick something that is electronic in nature. I would pick, you see how it says childhood? I would actually pick a child's toy for this activity. All right, something that has movement. Um, Make sure that it's something, if need be, in the future you could tear apart. Make sure you ask your parents' permissions for that. All right. But I would find a childhood toy that has some kind of function to it, um, design or operation. So you're going to put the product's name, the company name. What is the purpose or the primary function of the object? Sketch an isometric pictorial of the product on the attached isometric grid paper. Label the individual components. If you're not sure what a particular component is called, then make a logical guess. Make an educated guess as to how this product operates using simple machines terminology to explain the object's sequential operation. Again, this is why I'm saying pick a childhood toy. Okay, don't do anything electronic. No electronics. Okay, so I guess that's what you could say is your activity for the day, is find an object that's non-electronic that has simple machines abilities with it. Identify the system inputs, intended product function, and outputs in the table below. What mechanical components are visual? What is it about the device function that you cannot identify because the mechanical components are hidden from plain view? And then you have your conclusion questions. So again, we're just overlooking this, okay? So I'm giving you an idea of what it is you're going to be doing. So today is kind of like find something that is excuse me, simple machine oriented to do with this activity. So the next thing we're going to do is we're actually going to go over the PowerPoint. In this presentation, which is kind of in paper format for the simple fact of, again, we sent it to you guys as a paper, hopefully. So that's why it's in paper format. Now, in the presentation, it's DDP, reverse engineering, and function analysis. So we're going to talk about reverse engineering and functional analysis. So what is reverse engineering? Reverse engineering is the process of taking something apart and analyzing it in detail, usually with intention of understanding its structure, function, and operation. So right here you got like an image of a watch. For something like a watch, the older ones, you could kind of tear them apart, put them back together again. It wasn't that big of a deal as long as you were careful with the tearing apart part. Now, by seeing how something works, you can kind of understand what its purpose is or what its function is supposed to be. You can also see what materials were used, whatever have you. So here on the farm, when I'm trying to work on something, for instance, let's say it's my, what have I had to work on recently? All right, so I have a post hole digger that actually attaches to my tractor, and I was having issues where it wasn't working correctly. One of the gear mechanisms had frozen up. So I didn't know that because it was underneath something. So what I wound up doing was taking it apart and fixing it up, greasing it up, and finally figuring out what it was that I was having issues with. So sometimes when you're reverse engineering, it's because you want to fix something. Sometimes it's because you want to find out how something works. It completely depends on what you're doing. So why is reverse engineering used? Documentation. All right, maybe you need to document how something is done, how something is built. Discovery. So in my case with the post hole digger, I had to discover why it wasn't working. Why was nothing turning? Um, Investigation. Again, discovery could be a problem, but it also can be you're trying to look for something unique. Investigation is something you're looking for more of a designated problem. Product improvement. Sometimes you're looking at something and you wind up improving it. So you're like, okay, so I need to improve this product, but you know, I first have to figure out what the product does or how it works before I can improve it. So documentation it is done when there's no existing documentation, which I actually had to look that one up. Interoperability is when you have to um, kind of convert with computer software. I had to look that up. I had no idea what that word was. I was like, huh? Maintenance. So sometimes you have to document something to show how the maintenance of it works and different functions of that. Again, discovery. Academic, research, learning, curiosity. You're trying to find out what it works and how it works. It can actually be, sometimes this is used in military or commercial intelligence too. So you're trying to figure out how something works, and again, it can be military or commercial related. It depends on what it is exactly you're looking for. Investigations. So analysis, testing, documentation, document patent infringement. So sometimes you're investigating something to see how similar it is, and that's where the document patent infringement comes into play, because you're trying to figure out, okay, how is this product so similar to mine? And if it's a patent infringement, it can actually be an issue. So forensics, maybe you're looking for a design failure in your investigation. Maybe you're trying to figure out how to fix it. Improvement or redesign of a product. Increase efficiency. That's normally what you want to do when you're improving a product. You're trying to increase the efficiency of the product so that it's more reliable. Okay, so efficiency and reliability kind of go hand in hand. You're improving its. Sometimes you're improving a manufacturing technique. You're eliminating failure mode, reducing costs, increasing easy use, reducing negative environment impacts, recycling parts, etc. So you can go a couple different ways with why you want to do reverse engineering and how it's used. So some of the tools that are used in reverse engineering. Micrometers, calipers, optical probes, medical imaging, and handheld 3D laser scanners. Now, obviously, for us, we're kind of sticking with micrometers, calipers, and rulers for us. But, those are some things that other things you can take into consideration when you're thinking about reverse engineering. So, stages of reverse engineering. You have visual analysis, functional analysis, and then structural analysis. So visual analysis, we've already talked about. That's your principles and elements of design. Functional analysis is what we're actually going to be talking about. So functional analysis. After a product has been selected, a non-destructive functional analysis is performed. First, the product's purpose is identified. So you're trying to figure out what is the purpose of the object. Next, your observations are made to determine how the product functions. These observations are recorded in detail. Lastly, the system's inputs and outputs are listed. So what is the purpose? The purpose of a toothbrush is to clean teeth and gums to prevent tooth and gum decay. Water and cleansing paste are used in conjunction with the brush. So when you're looking for a purpose, you're trying to figure out what the intent of it is. In this case, we're talking about the intent of a toothbrush. Then, after you've done a function, an annotated sketch with all visual components is labeled. Components labeled is created. So you can see the toothbrush here. It has all its parts labeled. A hypothesis, kind of like in science class, is devised to describe in detail the sequential operation or function of the device using the sketch as a reference. So here you're trying to analyze, okay, I sketched my part, I labeled everything. Now, how does everything work together? And then we talk about inputs and outputs in systems. So a black box system model is used to identify what goes into and out of the product in order to make it work as a system. So you have inputs, product functions, and outputs. So an input is kind of what you put into the product. The product function is how it works, and then the output is what the outcome is. So the black box is used to represent the product's internal components or processes which are deemed unknown at this point. So here's the example they have. Hand motion, toothpaste, water, energy. So that's what you put onto the toothbrush. So your input is your hand motion. So that's you taking the toothbrush and moving it all over your teeth, putting the toothpaste on, the water, and again, your energy from moving your hand. The toothbrush itself, in this case because it's an electrical toothbrush, functions, meaning it moves, it does whatever, its internal mechanisms are moving. What you get after that is sound, because it does make a sound, heat, because whenever you put energy into something, heat is a byproduct, waste, and then ultimately you have clean teeth and gums, hopefully, if you did it right. All right, so that is why you would want to do reverse engineering. Okay. Now, again, I understand that this PowerPoint was slightly long, and this is all we're going to talk about today. You're not going to actually do anything in this. Okay. Today was just a talking point. So me going through this, and through this. Mainly because what I want you to do, and I'll actually put this in here. I want you to find preferably, find a toy or object with a function. So it actually has working parts. I'm going to emphasize cheap. All right. So again, this is what I want you guys to work on today. It's just finding something. Okay. So just find something, review everything I talked about. We're going to talk about simple machines on Friday. So we talked about reverse engineering, what that is and how it goes about that. We talked about what you're going to do. And we'll review simple machines on Fridays and some other activity points. Other than that, today's a pretty easy day. You just had to listen to me. So make sure that you actually listen to this video just in case you decide you were going to just skip through everything. All right, talk to you later. Bye.